So quite often you'll have, on page 22, you'll have more than one inequality on the same pane. So you have to treat one, you do one at a time. Okay, you don't mix them up. So you could call this, let's call this one inequality A, and this one right here, we'll call that inequality B. Right? So we have, if we do inequality A, if we tackle that one first, you realize it's a special case, correct? Well, let's figure out first, it's solid line, and where's the true region here? Where the solution is, right? Don't worry about the shading. If it says solution, you go, that's where the true region is. Because listen carefully to this part, if this had said solution, but this side was shaded, it just means that reverse shading was used, but it doesn't take away from the fact that the true region is to the right, okay? So if it's labeled, you go with it. So true is to the right side. I will add that this is a special case. That makes it actually very easy. It's a vertical boundary. So instead of y, you don't even bother with it, you just go x. True is to the right side. So which way is it opening? This way or that way? You have your study sheet. It should go this way, and because it's solid, I'm going to add the equal sign under. And there's a number that's going to go here. This one goes through 1, 2, 3, 4, 5, 6, 7. This is 7, 0 right there. So I know that this particular boundary line goes through 7. That's it. You're done. No need for slope. No need for y-intercept. That's it. Okay. Inequality B. Let's do that one. It's a horizontal line. But for now, we're just going to make note of the fact that it's dashed. Where is the true region? Below the line. And it's right here. I will make a note that this is also a special case. Makes it a lot easier. This is a horizontal. It's a horizontal boundary. So I will go y. If the solution is below the line, I go less than. Will I put an equal sign there? I will not, because it's dashed. Then it's just less than. Do not put an equal if it's dashed. And this one is going through, let me see here, 2, 4. This is 5 right here. This is negative 5. 6, 7, 8, 9. It goes through 0, negative 9 right here. So that means that negative 9 is the value that goes there. That is the inequality. So I take a lot of time. After a while, you'll just know. You'll just be able to, oh, vertical. Where does it go through? Solid, dashed, right? You won't be as systematic. You'll just have your way to do it. But you gotta find a method that's gonna help you. All right, let's keep going. These are diagonals. You know these are not special cases. Determine both inequalities. Then determine the point of intersection between the two boundary lines. We'll do that in a bit. Let's do, we'll call this inequality A, and we'll call this one inequality B. So if it's not clearly labeled, you just go for it. Okay. By the way, if I asked you before anything else, what kind of shading has been used, regular or reversed, what would you say? Regular, because the true region, for both of them, the true region has been shaded. that's a good observation to make. Let's do inequality A first. It's not a special case, so I need to, first and foremost, I'm going to say it's dashed, and the true region is above the line. It's diagonal. So I know that it's going to start like this. Y is greater than, that's it. I need to find my slope and my y-intercept. Let's do the y-intercept first. This would be 5, 10, 11, right? So it's 0, 11 here. So B is 11, and my slope, I'm about to find out what it is. Pick points. If I give you points, use those. Okay? So I'm going to use this one and this one here. So 1, 2, 3, 4, 5 to get to the next point in terms of vertical change. 1, 2, 3, 4, 5, 6, 7. So there's a run of 7 and a vertical change of 5. Okay, so I'm going to go 5 over 7, and you know this line is dropping. Therefore, you have to have a negative slope there. Okay, that's how I do it. Instead of figuring out, wait a minute, like, is it dropping 5? Is it rising 5? What is happening? Just count. Vertical change, horizontal change, boom. Okay. To make sure you're doing this right, you should be able to replicate 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6, 7, and you land right on the line again. Then you know this is correct. If you try this one more time and you're off, you're not on the line, try again, right? You probably miscounted or something went wrong. So now we have everything we need to finish this thing. Negative 5 over 7x plus 11. Make sure your signs are correct. And so this is the inequality for that first one pictured. Let's do inequality B here. It's solid, and the true region is below the line. And it's not a special case, it's a diagonal line, so I'm going to have y and x. Okay? But this is already going to give me enough to get started. Y, it's solid, right? So, and true is below. So I go below, and I put an equal sign because it's solid. I find my intercept. This is going to be negative 7, 0, negative 7. And my slope is, it doesn't matter if you do run first. Here's 3 and 1, right? 3, 1. I'm going to keep going. 1 up, 3 over, and it continues to be on the line. So my slope is 1 over 3x. Is it positive or negative? Going up, right? So this is technically positive. You don't have to have it there, but that's just for notes. And then followed by negative 7. And so that's your inequality there. Are you able to find your point of intersection here using your calculator? Yes, because you've got, this can, we can treat this as an equation when we enter it into our calculator. Same with this one. So why don't we go ahead and do that? Find where they meet. Okay? Find where they meet. Take a few seconds to do that. Make sure your calculators are well charged over these days, right? Because you're going to probably use them more to review and whatnot. So go ahead and try that. Make sure the leading coefficients are put in brackets before you enter it. And my window, so first of all, it kind of replicates this, but not, it may look a little different because they're different scales, right? But it still has that same trajectory where they meet. So if for example you had two lines that didn't seem to meet, you have a problem, right? You have to go back and check. Right now I cannot see the intersection, so I need to increase X max, right? This boundary here. I'm going to go 25 or something. There we go. And then I'm going to go ahead and find it. Because you only have two lines, you just go second trace intersect, and then just hit enter 3 times. The point of intersection, I went second trace 5 for that one. And that's 17.18 minus 1.27. Okay, so this is the point of intersection for this in this scenario. Okay.